morning, students. So in this session of the class, I am going to explain the next topic, what we call the mass wave optics. So in the previous all videos, we have discussed the theory as well as the numericals of ray optics. We have completed theory as well as numericals of ray optics. So in this session of class, so I will give some introduction, and also I am going to start the next topic, that is chapter number 10. Chapter number 10, it belongs to unit number 8. So the name of the topic is wave optics. So while studying the optics, I already told the light can be understood by two methods. The first method is with the help of rectilinear propagation of light. You know what is rectilinear propagation of light? So the light can always travels in a straight line. So with the help of rectilinear propagation of light, we already studied about ray optics. In ray optics, mainly we have discussed about reflection and refraction of light. So that we already completed. So that is on the basis of the main condition of the ray optics is the light is treated as it can travels in a straight line. That is what the phenomenon, what we call them as rectilinear propagation of light. So today the same light, what we call them as the optics, which belongs to the physics, which mainly deals about the phenomenon or study of light. So there the light can be understood by two methods. The first method is called the ray optics. The second is called wave optics. To discuss about wave optics, first of all, let us know some theories related to the light, isn't it? So actually the theory starts from the year 1637. So this was explained by Newton, isn't it? So from 1637 to 1900, it will take a long time to know about what is light, isn't it? So the theory related to the light is on this order. The first theory, what we call them as Newton's corpuscular theory. Corpuscular theory was proposed by Newton. That's why it is called Newton's corpuscular theory. This is the first theory related to the light, explained by, assumed by Newton, isn't it? So in the year 1637, this Newton's corpuscular theory was proposed by Newton. So according to this theory, the light is treated as a tiny particle. Tiny means very small particle. Very small particle. Tiny particle. This is one condition. Tiny particle. Very small. Second one is these particles are of different size. Different size. The size is different. So with the help of different size, they explain different colors. Different corpusculars having different size, it indicates the light is having different colors. And these two particles are highly elastic in nature. Elastic in nature. You know what is elasticity, isn't it? After the removal of deformation force, if it comes to the original state, then it is called elasticity. So these particles, what the Newton has assumed, tiny, different size, highly elastic, and they can travel with a very fast, high speed. They are moving with a very high speed. They are very fast. So with this condition, Newton assumed that so the light is a very small particle and it is having different size, and these particles are highly elastic in nature and they are very fast. And these particles, we name it as corpuscular. We name it as corpuscular. That's why this theory is also called as Newton's corpuscular theory. Corpuscular is an assumption made by Newton. So that's why. So what type of assumption he has made? Light is nothing but a small particle, tiny particle, very small particle of different size. They are highly elastic in nature and they can move it very fast. So with this assumption, Newton has explained the first phenomenon of light, because if you are assuming this condition for the light, they have to prove these conditions are satisfied. So the first condition he has satisfied is the reflection of light. So he has proved that light is rectilinear propagation because they are moving at a very high speed. If a particle is moving with very high speed, they can occupy a straight path. Okay, rectilinear propagation. And later on he has proved that reflection of light. So you know what is reflection? Reflection is nothing but bouncing back of light in the same media with the same speed is called reflection. So with the help of this condition he has successfully explained reflection. So which condition has taken? They have taken? They are highly elastic in nature. You know that if you throw a rubber ball to the ball will bounce back. Why the ball will bounce back? They have highly elastic in nature. The same condition he has assumed. Since the corpusculars are very highly elastic in nature, if it is incident on any opaque body, it will bounce back with the same speed in the same medium. So okay, it is acceptable. So what the assumption he has made? Elastic in nature, that helps to explain the reflection of light successfully. But while explaining refraction of light, you know what is refraction of light? Bending of light when it travels from one medium to another media is called refraction. According to Newton's corpuscular theory, he has used the concept of mechanics. So in mechanics, you know that he has used the concept of gravity. So what is gravity? Suppose if I consider one object, say this is another object, these two bodies can always experience gravitational force, you know that. So what is gravitational force? The force of attraction between any two bodies in the universe is called gravitational force. See, the smaller objects can always attracted by the bigger objects. Why we are all attracting towards the earth? Because earth is a huge mass. We are very small, tiny objects or bodies. That's why we are all attracting towards the earth. So that is because of gravitational force. The concept of gravity was given by Newton. You know that concept is used in light. So how they are used? So according to Newton, suppose say this is the media, we separate two media. Let us consider this is a rarer media and this one is denser media. So rarer media means the medium particles whose size is small. Denser media means whose medium particles whose size is larger. Suppose this is the medium, transparent medium. The medium particles are larger in size if it is denser. If it is rarer, the medium particle size is smaller. So according to Newton's corpuscular theory, light is a very tiny, very small. When this small mass or when this small body or light enters from rarer media to denser media, here the denser media particle size is larger. When the small corpusculars enters to denser media, this heavy mass can attract the corpusculars. So once the corpusculars is attracted by, tiny particles are attracted by the denser medium particles, the light speed increases. The light speed increases. This is what the assumption made by Newton's corpuscular theory. So what assumption he has made? So when a ray of light travels from rarer media to denser media, the speed of the light increases. Actually, you know that the speed of the light is not increases in denser media. Actually, it is decreases in denser media. But according to Newton's corpuscular theory, the speed is more in denser media than rarer media. So the reason I told, Why? Which concept he has taken to explain this Newton's corpuscular, this refraction of light? He has taken the concept of gravity. So according to that, when a tiny particles enters to this media, the medium particles are larger in size, so the larger body can attract always smaller body, you know that. That concept he has adapted. That's why he concluded that the speed of light is more in water, denser media. But this is against the experimental results of Michelson-Morley experiment. So later on, Michelson-Morley has proved that the speed of light is more in rarer media than denser media. So you know that. We can always accept experimental observation, not the theoretical observation, not the theoretical concept. Actually, theoretically, Newton said that the speed of light is more in denser media. This condition is against the experimental observation made by Newton's corpuscular theory. So that's why this Newton's corpuscular theory was discarded. It has eliminated. Isn't it? So why the Newton's corpuscular theory was discarded if they ask? So what is the reason for that? Because Newton's corpuscular theory, whose theory is against the experimental observation of Michelson-Morley experiment. So what is Michelson-Morley experimental result? The speed of light is more in denser media. The speed of light is more in rarer media than denser media. But it is against Newton's corpuscular theory. That's why this theory was discarded. So this is the first theory was proposed by Newton. So I will present once again. In the year 1637, Newton assumed that light is corpuscular in nature. It means they have one type of character: tiny, different size, elastic, and high speed. With the help of this, he has successfully explained different colors. Why the different colors he has successfully explained? Corpusculars are of different size, so different colors. He has successfully explained rectilinear propagation because the corpusculars are assumed to be very fast. If they are moving in very fast, it can occupy obviously straight path. And he has successfully explained reflection of light because he has assumed that in this corpuscular theory, the light is treated as highly elastic corpusculars. So elastic nature can successfully explain reflection of light. But he has failed while explaining refraction. According to theory, the speed is more in denser media, but this assumption is wrong because Michelson-Morley experiments proves that light is more speed in rarer media than denser media. Speed decreases in denser media actually, isn't it? So that's why this Newton's corpuscular theory was discarded. Okay, so I think you understood what I am explaining here. So let us come to the second theory. The second theory is around 1678, was proposed by Huygens. So Huygens has given the knowledge of wave concept, isn't it? So the concept of wave was given by Huygens. So that's why Huygens assumed that light is in the form of wave. Light is in the form of waves. It means, you know what is wave? In first PUC itself, we already studied what is meant by wave. Wave is a kind of disturbance. Wave is a kind of disturbance. So Huygens assumed that whatever the light we have considered, it is a type of disturbance. It can transport energy in the form of waves. Isn't it? So this theory was proposed by whom? In the year 1678, Huygens was proposed. Huygens has stated that light is a form of energy. Light is a form of energy which can be transmitted in the form of a wave, what we call them as disturbance. So the energy is transmitted in the form of wavelengths. Isn't it? So it is nothing but disturbance. Light is nothing but disturbance. So wave means they have wavelength. Wavelength. Isn't it? They have frequency. They have frequency. Wave is having a frequency. Wave is having time period. isn't it? So wave is having speed called wave speed, velocity of the wave. So all these fundamental things you already studied in first PUC last topic, waves topic. The same condition is applied in this here. So in that time, whatever the wave we has considered at that time, we have a knowledge of only one type of wave, that is what we call them as mechanical waves. You know what is mechanical waves? The waves required material medium for their propagation. So that's why I can assume that since the whole universe is assumed to be covered with an hypothetical media called ether media, so due to the presence of the ether media, the light is transmitted in the form of waves. Isn't it? The name of the hypothetical media is called ether media according to this Huygens wave theory. Isn't it? So in this topic, what we have taken wave optics, mainly we are concentrating on the knowledge of Huygens wave theory. So I will explain it later how we are considered. So this is the second theory. The light is assumed to be in the form of wave. This is second theory was proposed by Huygens. So this theory can successfully explain reflection, refraction, interference, diffraction. But this theory could not explain the phenomenon of polarization. It could not explain the phenomenon of polarization. So I already listed those. Reflection. Reflection is explained successfully. Second one is refraction. Refraction is also explained successfully. Rectilinear propagation is also explained by this wave theory. And the third one is interference. Interference is also explained. Diffraction is also explained successfully. So Huygens theory explained reflection, refraction, interference, diffraction. It fails to explain the phenomenon of polarization. So in this topic, wave theory, we are mainly concentrating on interference, diffraction and also polarization. So then, how the polarization can be explained successfully? To explain this polarization, so a famous scientist, what we call them, Maxwell's, yes, proposed a theory in 1865, what we call them as electromagnetic theory. Electro, it means light is having electric in nature as well as magnetic in character or nature. So the combination of electric and magnetic oscillations causes electromagnetic waves. So this is what mechanical waves and this is what non-mechanical waves. So who proposed electromagnetic theory? Maxwell's proposed electromagnetic theory in 1865, isn't it? So that's why. What is the concept here? Very simple concept. Light is not in the form of mechanical waves; it is in the form of electromagnetic waves. It means the light consists of the oscillating electric and magnetic field like this. Suppose the light is transporting in this direction. So it is having electric variations perpendicular to the direction of propagation. This is the direction of propagation. This is electric variation. This is electric variation. So when there is an electric variation, the variation in electric field causes the variation in magnetic field. So due to the change in electric flux, there is a change in magnetic flux perpendicular to this. So this is what the direction. The angle between these two variations is exactly 90 degree. So when there is a variation in electric field, so exactly perpendicular to the electric field, the magnetic field is varied. This is causes electric and magnetic variation. This magnetic variation causes again electric variations perpendicular to that in the opposite direction like this. Isn't it? Again, if this is varied means perpendicular to that, but again magnetic field is generated. Isn't it? It will be continuously varying. Electric field is varying, producing magnetic field. That is also varying. When there is a varying magnetic field, producing electric field. So this type of variation causes electromagnetic waves. So that is also called as mechanical or non-mechanical. This is what non-mechanical. Non-mechanical. It means So to produce this type of wave, there is no need of any material medium. Even in the absence of material medium, the energy is transmitted in the form of electromagnetic wave. So this was proposed by Maxwell's. So Maxwell's assumed that light is electromagnetic wave. It consists of varying electric and magnetic field produces electromagnetic. See, this is what the direction of energy, perpendicular to the direction of energy, electric field is there, perpendicular to these two, magnetic field is there, but electric and magnetic field is not fixed, it is varying. So that's why the varying electric and magnetic field can produce non-mechanical waves. It is also called as electromagnetic waves. So this electromagnetic waves proves the phenomenon of polarization, what we call them as transverse nature of light. So polarization is a transverse nature of light. So that can be explained by using non-mechanical waves, what we call them as electromagnetic waves. Clear? Okay. So now Eigen's-Ray theory cannot explain polarization. It can explain the rest of the things, reflection, refraction, interference, diffraction. It could not explain polarization. But Maxwell's electromagnetic theory can also explain all the 4 plus polarization, isn't it? So, but this Maxwell's electromagnetic theory could not explain photoelectric effect. So photoelectric effect is not explained by the Maxwell's electromagnetic theory or Eigen's-Ray theory or Newton's corpuscular theory, but the photoelectric effect. So you know what is photoelectric effect? It's a fundamental definition. Photoelectric effect is the conversion of light energy into electrical energy. So the conversion of light energy to electrical energy was first invented by a famous scientist called Hertz. But this should be explained by Einstein by the knowledge of Planck's quantum theory. So in the year 1900, so 1900 is the year which can change the concept of physics. So due to the proposal of a quantum theory. So from quantum theory onwards, a new era physics, what we call them as modern physics. Modern physics or nuclear physics is successfully explained quantum theory. So the basic concept of quantum, you know that what is quantum? Quantum is nothing but a packet of energy. So the light is a packet of energy, a small packet of energy. So quantum is, the meaning of quantum is, it is already small, again we never divide. So that is meaning of quanta. So quanta is nothing but a packet of energy. So it is a very small packet of energy. The meaning of quanta, how to explain quanta? Suppose in a classroom there are 60 members, right? So today in this class, so if I take the attendance, there is a presence of 60 students, isn't it? So suppose tomorrow one student is absent. How many students are present in the class? 59 students, isn't it? So day after tomorrow, 2 students are absent. So how many students are present in that class? 58 students. Is there any possibility of 58.5 students? Never, because we never divide that, isn't it? So we never divided. The meaning of we never divide again, that is nothing but quanta. Very small packet of energy. Each packet of energy is equal to h nu. The energy depends on the frequency of vibration of that packet of energy, where h is called Planck's constant. So I will explain in detail in one of the topic is quantum theory, isn't it? Okay, here just you remember who proposed quantum theory? Max Planck in 1900. Okay, according to this theory, light is a packet of energy, what we call them as photon. Photon is a packet of energy, especially light energy. So it's a packet of energy. With the help of this, it can successfully explain photoelectric effect. But this theory could not explain the interference, diffraction, polarization. See here, the famous theory, it can successfully explain photoelectric effect, but it could not explain the interference phenomena, diffraction phenomena. I will tell in detail what is interference, diffraction and polarization, because in this topic we are mainly concentrating the definitions and phenomena and experimental observations of interference, diffraction and polarization. Isn't it? Okay, but Planck's quantum theory successfully explained the phenomenon of photoelectric, because this photoelectric effect is due to the effect of light. We are converting light energy into electrical energy is explained by Einstein by using Planck's quantum theory, right? Sorry, Planck's quantum theory. So that is explained successfully, could not explain interference, diffraction and polarization. So this is around in 1905, the photoelectric effect was explained, because in your syllabus there is a separate topic, photoelectric effect. There I will explain in detail about this phenomenon, photoelectric effect, and how he has used and which is the concept they are included by Einstein, right? So the Einstein successfully explained the phenomenon of photoelectric effect by using Planck's quantum theory in 1905. So the confusion gets started. At that time, the people were not accepted what the Einstein has given, the concept of the photoelectric effect. So the reason is, the light is assumed to be wave in nature. He is assumed that light is also assumed as what? Particle in nature. The light is assumed as a particle in nature here, because the photon is assumed as a particle whose energy is equal to mc square, where m is mass and c is speed of light. E is equal to h nu quanta. This quanta is assumed to be E is equal to mc square. So I will use these two equations in one of the chapter, what the photoelectric effect, in the next coming topics. Okay. So finally, in 1923, it will take around 14-13 years afterwards. Actually, in that year 1923, Einstein has got Nobel Prize. He has successfully explained in the year 1905, but at that time the people were not accepted this theory, because it is a theory, there is no experimental evidence. But in 1923, de Broglie has made a famous, in 1923, de Broglie has given the theory called de Broglie hypothesis, but in 1923, so there is an effect called Compton effect. Compton effect. So this is the direct experimental evidence of the presence of photon. So this is only theoretical concept given by Einstein. But in 1923, Compton has made an experiment called Compton effect. That is the direct experimental evidence of the presence of photon. So at that time, the people were accepted that light is a wave, but in some circumstances, light is also considered as a particle in nature. Particle in nature. Isn't it? Actually, light is a wave. Not in all the cases, light is considered as a wave. See here, in some circumstances like photoelectric effect, light is treated as what? Particle in nature. Actually, light is a wave in nature. In some circumstances, light is also treated as what? Particle in nature. So that's why the light is treated as both the character. One is already wave in character, but in some circumstances, light is also considered as what? Particle in nature. That's why the light is considered as dual nature of light. This is comes in 1923. Clear now? So why the light is considered as dual in nature? So a single theory could not explain all the phenomenon of light. Isn't it? Because quantum theory could not explain interference, diffraction and polarization. But it can explain what? Photoelectric effect successfully. Isn't it? So that's why. So whatever the theory we have taken, a single theory could not explain all the phenomenon of light. That's why. So depending upon the situation and the phenomenon of light, light is treated as dual nature of light. If you are considering interference, diffraction, polarization, at that time don't take light as a particle in nature, you take light as a wave in nature. But at the phenomenon of photoelectric effect, we cannot take light as a wave in nature, we can take what? Particle in nature. So it means if you are assuming that light is a particle, we never take it as a wave in nature at that time. If you are considering light as a wave in nature, we never take it as a particle in nature. So that is the meaning of dual nature of light. Simultaneously we cannot take both the particle as well as wave in nature. If it is in wave in character, okay, wave only. So at that time we cannot assume particle in nature. If it is particle in character, we never take wave in nature. So that is the meaning of dual nature of light. So what is the meaning of dual nature of light? Light is treated as both particle as well as wave in nature. Simultaneously we cannot consider both the character at a time. Clear? So with the help of this Huygens wave theory, so the next concept I am going to explain is wavefront. So dear students, in the next video I will explain in detail what is wavefront and what is Huygens principle. Okay, thank you one and all.